Determine the quadrants for where the following is true. Okay, so we got a little thinking to do. Cosine theta and cosecant have opposite signs. All right, so that means where this one's positive, this one's negative, or this one's negative, this one's positive. All right, so let's kind of go through. We know in quadrant 1, all are positive, so that would not be an answer here because they couldn't be opposites. In quadrant 2, sine and cosecant are positive. Well, cosine's not positive, so it must be negative, so in quadrant 2, this would be true. Okay. In quadrant 3, tangent and cotangent are positive, which means both cosine and cosecant are negative, so not in quadrant 3. In quadrant 4, cosine and secant are positive, so that means cosecant has to be negative, so also in quadrant 4 they are opposite. Okay, so cosecant theta is negative and tangent theta is positive. Alright, so tangent theta is only positive in the first and the third. Okay, so that happens in the first and the third. Cosecant, however, is not negative in the first quadrant. Nothing's negative. Let's see, it is negative in the third quadrant, so the third quadrant is our only choice there. Okay, cotangent theta and sine theta have the same signs. Okay, so they would both be positive or both be negative. Okay, well, everything's positive in the first quadrant, so we know in the first quadrant they would have the same signs. Okay, in quadrant 2, sine is positive, but cotangent is not. In quadrant 3, cotangent is positive, but sine is not. And in the fourth quadrant, they're both negative, so that's going to be the other quadrant for that. All right, now this next section, draw each angle theta in standard position, find the reference angle alpha, and label both theta and alpha. So let's take a look here. 144 degrees. Okay, standard position, so draw axes. We're going to start here, 144 degrees. We're coming across, and it'd be somewhere in this quadrant. I think I've gone a little past where it would be, but that's roughly 144 degrees, so that's theta. Okay, then find the reference angle alpha. Well, alpha, if you'll recall, is the distance from the terminal side to the x-axis, shortest distance, so that's going to be here. Okay, so this is 180 degrees. This is 144 degrees. So alpha will be 180 degrees minus 144 degrees, which is 36 degrees. And we label our alpha there. Alright, so 295 degrees. Again, we start with our axes. We're going to start here at x-axis. We're going to go around. There's 180, 270, and a bit more. Okay, so we're coming out in the fourth quadrant. Okay, so that's our theta. And then the distance from our terminal side to the x-axis, shortest distance, is our alpha. Okay, so this was 295 degrees. This was 360 degrees. 360 minus 295 is 65 degrees. Yeah, let's try another one. Okay, we have radian measures, so we're going to go with our radians in the quadrants. Right, so start again at 0, come around. That's pi over 2. Not there yet. We're at pi. Still not there yet. Okay. In fact, if we go by fourths, right, halfway, 1, 2, 3, 4, 5, 6, 7 pi over 4 is going to be over in this quadrant. Okay. So we're going there. Alright, so there's our theta. And this is 7 pi over 4. and this is 2 pi. Here's our alpha. Okay. So I'm going to say 2 minus 7 over 4. And you can use your calculator if you need to. It will be pi over 4. Okay. 5 pi over 8. Alright, let's see, we start here. This would be 4 pi over 8, so 5 pi over 8 is going to be just a little bit more. That's our theta. Our alpha is going to be the distance to the x-axis, and that's where pi is located. And since I know it's 1 pi, I'm going to say 1 minus 5/8 pi, and that would be 3/8, or simply 3 pi over 8. Okay. Alright, if the terminal side of an angle theta passes through the point -3,9, determine the numerical value of all 6 trig functions. Alright, I better clear some room here. These other things are going to be in my way. Okay. So, going to do a little bit of a sketch here. Right? I know that if I go -3 and +9, I'm going to end up somewhere up in here in the second quadrant. This is a distance of 3, but we're going to call it -3. This is a distance of 9, it's positive. Okay? And now we need, this is our x value, this is our y value. Now we need to know what our r value is. Okay. So remember, x squared plus y squared equals r squared. So we know that it's going to be -3 squared plus 9 squared equals r squared. And -3 squared is 9. 9 squared is 81, so that comes to 90. So we take the square root of both, and we get r equals, and now it gets a little tricky, right, because we got to simplify. Well, I know that this would be the same thing as the square root of 9 times the square root of 10, and square root of 9 is 3. That'd be 3 square root of 10. 10 is just 2 times 5, no perfect squares there, so that is the simplified version. R is always positive, so I'm ready to set up my trig function. Okay, so sine, which was y over r, will be y, which is 9, over r, which is 3 square roots of 10. Now, first thing I notice is that 9 and 3 are divisible, so I'm going to go ahead and divide that out. And then square root of 10, I don't like to leave that, so I'm going to multiply both the numerator and denominator by the square root of 10. And I get 3 square root of 10 over 10. Okay, moving on. Cosine theta will be x over r, so -3 over 3 square root of 10. And again, 3 and -3 are divisible. So I now have -1 over square root of 10, but I don't like to leave a radical in the denominator, so I multiply both the numerator and denominator. I get square root of 10, negative square root of 10 over 10. Okay. Tangent is y over x. So y is 9, x is -3, which simplifies or reduces, however you'd like to say it, to -3. Okay. Cosecant. It's a reciprocal, so it's going to be 3 square roots of 10 over 9. Three and 9 are divisible. So we get the square root of 10 over 3. Okay. Secant theta. It's the reciprocal of cosine, and that's going to be 3 square root of 10 over negative 3. And then we see that 3 and negative 3 are divisible, so we get negative square root of 10. And then finally cotangent. Be the reciprocal of tangent, so that's negative 3 over 9, which reduces to negative 1/3. Right. Not bad. Okay, let's try another one. Right. So if cosine of theta equals 1/4 and pi theta is between pi and 2 pi, sketch the angle theta and find the value of the other 5 trig functions. Alright, so we are going from pi to 2 pi, somewhere in here. Okay, and it says cosine theta is 1/4. Alright, cosine is x over r. So x equals 1, r equals 4. Okay, so if x equals 1, we go to the right, but since we have to be in one of these two quadrants, right, and we have to be in one of these two, the only overlap is here. Okay, so our theta that back up. Okay. Our theta is like that. Okay. So we also know that on our triangle we have 1 and 4. Okay. So we want to take 1 squared plus y squared is equal to 4 squared. So 1 plus y squared equals 16. Y squared equals 15. So y is the square root. Okay, and 15 is 5 times 3, which are both prime, so it just stays square root of 15. Okay, but we had to go down. So this is a negative square root of 15. Okay, so find the value of the other 5. We know cosine, so we'll need sine theta, tangent theta, cosecant, secant, and cotangent. Alright, so sine is y over r, so that's going to be negative square root of 15 over 4. No reductions, so that's it. Alright, tangent is y over x, so that is negative square root of 15 over 1, or simply negative square root of 15. Cosecant theta is the reciprocal, so 4 over negative square root of 15. Multiply numerator and denominator by square root of 15. And we get negative 4 square roots of 15 over 15. Okay, secant theta is the reciprocal of cosine, so that's 4 over 1, or simply 4. And cotangent is the reciprocal of tangent, so we get 1 over negative square root of 15. And we get square root of 15 over 15, and that is negative square root of 15 over 15. All right.